Good afternoon, guys. Welcome back to my channel. So in this lecture and lab, we're going to talk about wireless. And at the end of this lab configuration, we're going to, at the end of this lab lecture, we're going to configure a basic wireless LAN simulation. So again, you can find this PDF book in the bottom of the description page on this video. So this is a CCNP/CCIE book for this Encor 305-41 official cert guide from Cisco. So this is chapter 17. It speaks about wireless signal and modulation. So it says this chapter covers the following subject: understanding basic wireless theory and carrying data over wireless signal. So wireless WAN must transmit a signal over radio frequencies to move data from one device to another. Transmitters and receives can be fixed in consistent location, or they can be free to move around. So this chapter covers the basic theory behind wireless signal and the method used to carry data wirelessly. Now, guys, these are the questions that on each chapter it's being asked to test your understanding about this topic. So I can leave this here as like I said, I'm going to provide a link of this book in the bottom of the page on the description section. So see here it says understanding basic wireless theory. So to send data across a wired link, an electrical signal is applied at one end and is carried to the other end. So the wire itself is continuous and conductive, so the signal can propagate water easily. A wireless link has no physical strength of anything to carry the signal along. How then can an electrical signal can be sent across the air or free space? Well, consider a simple analogy of two people standing far apart, and one person wants to signal something to the other person. They are connected by a long and somewhat loose rope. The rope represents the free space. The sender at one end decides to lift his hand off the rope high and hold it there so that the other end of the rope will also raise to notify the partner. So after all, if the rope were a wire, he knows that he could apply a steady voltage at one end of the wire and it will appear at the other end. So there go the signal, there go the illustration of what we're saying. This is the sender and there go the receiver. I think this is a very good analogy. So the sender decides to try a different strategy. He cannot push the rope towards the receiver, but when he begins to wave it up and down in a steady, regular motion, a curious thing happens. A continuous wave pattern appears along the entire length of the rope. So I shows this here. So in a free space, a similar principle occurred. The sender, a transmitter, can send an alternative current into a section of the wire, an antenna, which sets up moving electric and magnetic field that propagate out and away from the wire as traveling waves. The electric and magnetic field travel along together and are always at right angle to each other as shown in this figure. It's electric field. So electromagnetic waves do not travel strictly in a straight line. Instead, they travel by expanding in all directions away from the antenna. To get a visual image, think of dropping a pebble into a pond when the surface is still. Where it drops in, the pebble sets the water surface into a cycling motion. The wave that results begins small and expand outward only to be replaced by the wave in free space. The electromagnetic waves expand outward in all three dimensions. So now it says the idealistic antenna does not really exist, but serves as a reference point to understand wave propagation in a real world. Antenna can be made in various shapes and forms that can limit the direction that the wave are sent. So chapter 18 talk about wireless infrastructure antenna in more details. So that's the sender and there go the receiver here. So understand the frequency. So guys, I think this is a very interesting topic. Like I said again, if you're interested on know, not just being able to to make those configurations, but to have the knowledge and be able to explain this to somebody and make them understand. So you could, come on, into the bottom of the description page, you will find a link where you could have this book yourself. So here, let's see, let's talk about one or two mean frequency range used for wireless LAN communication lies between 2.4 and 2.48 gigahertz. This is usually called the 2.4 gigahertz band, even though it does not encompass the entire range between 2.4 and 2.5. It is much more convenient to refer the band name instead of the specific range of frequency included. So let's go down here. Now, before we jump into this lecture, before we jump into this Word document that I prepare here as a lecture from document that from article that I gather from this book and other articles. So you might have noticed that the most of the 5 gigahertz band are contiguous except for a gap between 5.350 and 5.470. At the time of this written, these gaps exist and cannot be used for wireless LAN. However, some government agencies have moved to reclaim the frequency and repurpose them for wireless LAN. Efforts are also on the way to add 5.8 to 5 through 5.9 to 5. So it is interesting. Bang, bang, bang. So there go the channel, it's always just a second. So center frequency, wave band, non-overlapping channel spacing. So how can channel be numbered such that signal overlap? Sometimes the channel in a band are defined and numbered for a specific use. Later on, another technology might be developed to use the same band and channel, only the newest signal might require more bandwidth than the original channel numbering supported. Such is the case in the 2.4 wireless band. So the overlapping channel, understanding phase. C, measure wavelength. So they said, so why don't you go ahead and jump on the lecture note that we prepare here. So local, a wireless local area networking. So a wireless local area networking wireless LAN provides wireless network communication of a short distance using radio or infrared signal instead of traditional network cabling. So what does wireless LAN mean? Question mark. Well, wireless mean wireless. Okay, WLAN means wireless local area network. A wireless can be built using any of several different wireless network protocols, most commonly Wi-Fi or Bluetooth. Network security remains an important issue for wireless LAN. Wireless clients usually have their identity verified the process called authentication. When joining a wireless LAN, technology such as WPA raise the level of security on wireless networks to rival that of traditional wired networks. So wireless pros and cons. So pros that support a large number of devices. Setting up a wireless is easier than laying cable for wired network. Accessing a wireless is easier than a wired LAN. Cable length isn't a factor. And last but not least, wireless are common outside of businesses and homes, like in public area. Now the cons, it's easier to hack a wireless link, which is why encryption is necessary. Wireless interference can hijack the speed and stability of a wireless network. More wireless devices like repeater are needed to expand the wireless network. Now, wireless devices, a wireless can contain as few as 2 devices and as many as 100 and more. However, wireless networks become increasingly difficult to manage as the number of devices increases. Wireless LAN can contain many types of devices, including mobile phones, laptops and tablets, computers, internet audio systems, gaming console, other internet-enabled home appliances and devices. So wireless hardware and connections. Wireless connection work using radio transmitter and receiver built into client devices. Wireless network don't require cables, but several special purpose devices also possessing their own radio and receiving antennas are usually used to build them. So local Wi-Fi network, for example, can be constructed in either of 2 modes, ad hoc or infrastructure. So Wi-Fi and ad hoc mode, wireless consists of peer-to-peer direct connection between client with no intermediate hardware component involved. Ad hoc local network can be used to make temporary connection in some situations, but they don't scale to support more than a few devices and can pose security risk. A Wi-Fi infrastructure mode wireless uses a central device called the Wireless Access Point AP that all clients connect to. In home networks, wireless broadband routers perform a function of an access point plus enable the wireless link for home internet access. Multiple access point can be interfered to either connect multiple wireless into a larger one. Some wireless LAN extend an existing wired network. This type of wireless is built by attaching an access point to the edge of the wired network and setting up the access point to work in bridging mode. So guys, last but not least, so wireless versus YWAN. So cell networks support mobile phones that connect over long distance, a type of wireless wide area network, which is WWAN, that distinguishes a local network from a wide network, or the usage model they support, along with some rough limits on physical distance and area. A local area network covers individual buildings or public hotspot spanning hundreds of or thousands of square feet. Wide area network cover cities or geographic regions spanning multiple miles. A wireless a wireless LAN is a wireless computer network that links two or more devices using wireless communication to form a LAN within a limited area, such as a home, school, campus, or office building. A wireless a wireless LAN is a network system wherein Wi-Fi is one of the most common technology in this system. Therefore, wireless LAN includes Wi-Fi. So benefits of wireless, let's touch this real quick and then we'll jump into the lab configuration today. So wireless technology first appeared in the United States. It was primarily used as a wireless extension of the last miles network and was mainly applied in households. At the point, the American people had a strong demand for wireless internet access due to the cabling difficulties. Most Americans live in the villas with courtyards and the popularity of laptops and tablets. This is in turn accelerated the proliferation of wireless. So compare with hardwired wireless have the following benefits. It's high mobility, it is easier to connect to wireless that are free from cable, port, location constraint. Spec wireless ideal for scenarios where users are often moving, such as in office building, airports, halls, resorts, hotels, stadium, and cafe. So it's flexible deployment. Wireless provide wireless network coverage in a place with difficult cabling, such as a subway, a roadway. Wireless network coverage eliminates or reduce complex cabling, thereby simplifying deployment, reduce costs, and facilitating scalability. So is wireless and Wi-Fi is the same. So Wi-Fi is a trademark of the WFA and is also a wireless network communication technology based on IEEE 802.11. The WFA has announced the use of Wi-Fi to improve the interoperability of products in compliance with the IEEE 802.11 standard. So wireless is the short for wireless local area network. Quite simply, wireless provides network communication using radio waves such as laser and infrared signal instead of physical connection. So they provide wireless network communication using high frequency radio waves such as those of 2.4 gigahertz, 5 gigahertz frequency band, and comply with IEEE standard. Wireless in our daily life refers to the implemented based on the IEEE 11 standard. During the evolution and development of the wireless, various technical standards have emerged, such as Bluetooth, Wi-Fi, and hyperlink 2. Among them, Wi-Fi is now most commonly used due to its advantage, such as simple implementation, reliable communication, high flexibility, and low implementation costs. Gradually, Wi-Fi becomes a synonym of WLAN, which is wireless local area network. So I think this is enough of yeah, it's not secure. We know that it's more risky. I already touched that. So tell you what, guys, why don't we go ahead and just jump on this lab configuration before this, I mean at the before we end this lecture today. I mean, if you want to, you could always pause this video yourself and just check on different things that let's see cloud-based deployment. So cloud access point provides similar function as FAT access point and can be deployed to build small wireless in home or SOHO, which is small office home, and then environments similar to the AC plus FIT AP, I mean access point architecture, the cloud management platform plus cloud access point architecture allows cloud access point to be centrally managed and controlled by the cloud management platform. Therefore, this architecture is also applicable to large and mid-sized networks. Okay, how does wireless works? We already touched this. Okay, so tell you what, guys, so let me go ahead and just jump into this lab configuration for today. See what we have. Okay, let's go ahead and just make this according to the way that we want this to be. See if we can make this large. Oh yeah, small. That's right. Yes, all this. Okay. So here we have okay. So the lab objective says configure a basic wireless LAN on the wireless LC. LC. So on what we have devices, router 1, switch 1, laptop, and these devices, which is the access point. Okay, so we have the admin PC and the wireless. So what am I doing? Okay, so on this lab objective today, what are we going to do? It says the lab objective in this lab, you will explore some of these features of the wireless LAN controller. You will create a new wireless LAN controller. Bang, bang, bang. Then you can configure wireless host or whatever. So it says to connect to a wireless LAN controller using the GUI. Explain some of this information that is available. The monitor screen, configure wireless LAN. Okay, implement. Okay, so first thing says part 1, we have to monitor the wireless LAN. Wait until the STP has converged. Bang, bang, bang. Okay, so we're gonna go to this one here. That's what it says. That gotta go to this. Then we go here. Okay. So we gotta grab this IP address. That's what it says here. So it says enter the management IP address of WLC. One from the addressing table. Yeah, into the bar. Must specify the HTTPS. So let's do that. I go to management IP address. Let's grab it. Let's copy. Let's paste it here. And let's hit go. Let's make this HTTPS, make the S. and hit go. Okay, so let's make this bigger so everybody can see. We're gonna hit login. So now press Control C to go back to this page. What it says? It says that we gotta use the username is admin. Let's copy it and let's paste it here. And back to here, let's say the password is Cisco123 with capital C. So let's copy it and let's paste it here. Say login. What do we do? Okay, so let's go ahead and type it into admin. Take admin with capital M. Then this is Cisco 123. And hit login. Okay, so hit login. Okay, so we in. Now, how can we make this more? How can we make this? How can we zoom into this so everybody can see? Okay, so let's go back to the instruction. All right, so it says that we have to scroll to the monitor, screen. What can we learn? It's the access point connected to the AP. Whatever. Okay. So here's what it says here. Click on wireless. Choose this. Okay. And it says we have to create. So hit go. And then it says, yep. So we gotta name this the profile. So enter into the wireless profile name of the new wireless name. Use the profile name, which is this name here. Let's copy it. Copy. Let's paste it here. Let's go back to this. And then we gotta use the SSID as SSID 5. So let's copy and let's paste it here. Then we change this name into 5. Then we hit apply. Just give it some time. Okay. So what else it's saying? It says to select the ID for the wireless. Okay, I already done that. Hit apply. Now it says now that the wireless has been created, you can configure features on the network. Click the enable. Hit enable. What else is saying? Click the enable. Am I okay? To make the wireless functional, it is a common mistake to accidentally skip these steps, so don't do that. So choose the wireless, choose the VLAN interface that will be used to the wireless. So let's go ahead and choose the VLAN interface. And what else we do? Let's go back, choose the VLAN interface. Yep, using. So then it says we got to click the advanced button. So we click it. What do we do on the advanced button? Click the advanced, scroll down into the Flex Connect portion, and then click to enable these two flex, and then click apply. So let's doing that. So these, we gotta click on them. Then we hit apply. That's what we were told. So as we hit apply, let's go back and see what we've been told again. Click apply to enable the in your wireless LAN. If you forget to do this, the wireless LAN will not operate. Okay, so it says secure the wireless. So to secure the wireless, we gotta go here, click security. Then what do we do? It says we gotta click on layer 2. You have to do the WPA plus WPA2 from the layer 2 security. Drop down, yeah, we do it. So we can do that. Let's go ahead and do it. This one. Then what else can we do again? Let's follow the instruction from the layer 2 security drop down box. This will reveal the, yep, we get that. So click on the dot. So click on the check box to the WPA policy. Where is that? Oh, WPA. Okay, WPA policy. Let's see. Click on the checkbox for the click on the checkbox for the WPA policy. This will reveal additional security settings under the authentication key management to enable PS. WPA policy, just that. Right, so just WPA policy. And then check the box for WPA2 policy. See? Okay. This says here, it says click the checkbox next to the WPA2, next to WPA2 policy. This will reveal additional security settings under authentication key management. Enable PSK. Okay, right there. So it says enable PSK. Then it says you can now enter the pre-shared key password. We type that in right there. So the password have to be what? Let's go ahead and just copy it. Oh, let's grab this, copy, let's paste it. And then let's go back over there. It says you can now enter the pre-shared key that will be used by host to join the wireless LAN. The phrase, so click applied. So it should be good. Let's hit apply. Then hit OK. Okay. Now we should hit. Let's get back. Let's see. It's pretty good. Now it says now note that if this is not a good practice to reuse password when configuring security, we use password in this activity to simplify configuration. So verify the settings after applying. After applying the configuration, click back. So it says click back. Okay, let's see what else is saying. Click back. That will take you back to the wireless screen. What information about the new wireless is available on the screen? If you click on the wireless ID, I have that right. That will take you to the wireless editor. Okay, so on part 3, this is the part that we concern right now. It says to connect the host into the wireless. So connect the host into the wireless to verify. Let's go ahead and do that. So let's go ahead and just minimize the screen as we're done with this right now. So this is what we concern right now. So we go to desktop, wireless. We're gonna hit connect. We're gonna hit connect. Then we're gonna type in the same password. Let's see if we could paste it, because that was the last password we've been using. And then we hit connect. Let's hit connect. Oh, we already, let's see if we connect already. Let's see if we connect already. How do we see that again? Okay, so here, let's see if we connect. So we're using the HCP. It's a sign that shows that we connect, but let's double check again to make sure. Let's go to this. So yeah, see this sign here shows that we connect already. Let's go here. So it says you have successfully connect to the access point. So we connect. Now to double check that we have done everything right, let's grab the IP address of this device and then see if we can ping it from, let's go to desktop, let's close this, let's go to IP configuration, let's grab this IP address, let's copy it, then let's pull up the wireless host, then let's close this. Now let's ping, see if we connect to it. So we're gonna hit ping, and then we paste this IP, paste, see if we get connection, just a proof that shows that we connected. Hold up, so yep. So that's pretty much all that we had to do in this lab configuration. So just so you know, let's see again. So of course we connected. So again, thank you so very much for following along with me. That was a pretty simple lab, but which can be very complicated if you miss one step of the instruction that being provided. So if you have a question or comment, you could always reach out to us and we'll be more than happy to commute with you. So thank you again. Bye-bye. You will have all this material at the bottom of the description page.